This is problem number 6 from our review packet, and I already set up the chemical equation for us, which is step number A, the balanced equation. And if you look at your rules of solubility, you'll know that your lead, what is this? Yes, this is your potassium iodide is going to be your solid. So, anyways, it says for part B, it says calculate the mass of precipitate produced when 50 milliliters of 0.50 molarity potassium iodide solution and 75 milliliters of 0.55 molarity lead 2 solution are mixed. So we're going to start with, we're going to try to find the moles of Ki. So it gives us the molarity and it gives us the milliliters, and we need to know the formula that molarity is what this capital M means. Molarity equals mole, which can be abbreviated MOL over liters. Okay. So since we're trying to calculate the moles, we're given that the molarity is 0.45, and the liters is 50 milliliters. Now, again, we just did a variation of the formula where we changed the liters times the molarities equals the moles. And for this case, we need to know that 0.5 milliliters is the same thing as 0.05 liters. So when we multiply these two together, we get our moles to be equal to 0.0225. Okay, and now we're going to do the same thing for our lead nitrate. We're going to multiply our 75 milliliters and our 0.55 molarity solution. And we need to know that 0.75 milliliters is 0.075 liters, so it's times the 0.55 molarity. So the total number of moles is 0.0413. Okay, so now we know the moles of both of these. And so what we do from there is that we need to figure out which one of these is the limiting reagent, since we want the mass of the precipitate, which will be our PBI. So we need to know that our limiting, there should be a 2 right here. We need to know which one our limiting reagent is. And since and we know that the 0.0225 is less than our lead nitrate. So our limiting reagent will be our potassium iodide. And then now since the relationship between the potassium iodide, because that's what we're going to be working all of the rest of the math off, and the lead iodide is a 2-to-1 molar ratio. So we know that if there is 0.0225 moles of this, because there is half the number of moles of this, we'll take this number and we'll divide it by 2, and that will give us the moles of our PBI. And when we divide it by 2, we get 0.0113, and that will be mole PBI 2. Okay, so now we know how many moles of PBI 2 we have. So now we need to change our moles into grams. And we said earlier that our formula for moles equals grams over formula mass. And the formula mass for PBI is 461.01. So we'll multiply these two together to find out how many grams there are, and that's 5.21 grams. Okay, so that gives us our answer for part B. what is the mass? Now it says calculate the volume of a 0.50 molarity potassium iodide required to react completely with a 50 milliliters of 0.5 molarity lit 2 nitrate. Okay, so now we start with knowing that our moles of PbNO32 is 0.0413. Okay, I'm sorry. We need to start by, it starts completely different. Ignore that fact. Okay. So it says that we need to calculate the volume of the potassium iodide required to react with this number of molarity. So we're trying to find the moles, except we're trying to find a new amount of moles that gives us for 50 milliliters times our 0.5 moles for molarity. 0.5 molarity for moles. So our moles is going to be equal to 0.025 moles. Okay, so our new number of moles for PbNO32 is 0.025 moles. Okay, then now we need to know how many moles of potassium iodide we need. So since there's only, if we look at our mole ratio, we have 1 mole of this and 2 moles of this. So we'll need twice the number. So we'll multiply the number of moles by 2. So we'll get 0.05 moles. So now we know that there's 0.5 moles of potassium iodide. So as calculate the volume. And we said earlier that molarity equals moles over liters. Okay, and the liters is what, the liters at the bottom of this formula is the volume that we are looking for. And it says in the problem that the molarity is 0.5, and we just found that the moles was 0.05 over liters. Okay, so if we multiply the 0.5 times, if we change the formula around, okay, we move the liters over here, and now we want to move divide by the 0.5, so we're going to divide by the 0.5, and our answer is 0.1 liters. So that tells us how many liters, and we can either leave the answer in 0.1 liters, or we can change it to 100 milliliters. So that is how you find the volume. Thank you for watching.